For centuries, humans have gazed across the Strait of Gibraltar, captivated by the sight of two continents so close, yet separated by a narrow ribbon of water. People have long imagined a bridge between Europe and Africa, a bold link uniting worlds apart. Here, Spain and Morocco nearly touch, just 14 kilometers apart at the closest point, a distance that feels almost within reach. The dream is more than a bridge, it's a vision of unity, connecting not just two countries but two continents, cultures, and histories. Imagine driving from Paris to Cape Town without a ferry, an unbroken road across history, geography, and generations. This vision has inspired generations, from engineers to everyday dreamers, sparking creativity and debate across borders. For over a century, proposals have come and gone, each facing immense challenges, some technical, some political, and some simply ahead of their time. If we can send people to the moon, why not bridge this narrow sea? The question lingers, echoing through decades of ambition. The answer, nature's obstacles, staggering costs, and political complexities, reminds us that some dreams are harder to realize than others. Yet the idea persists, a symbol of unity, ambition, and the hope for a future where borders are bridges, not barriers. Today we explore why this gap remains, despite our technology, our resources, and our collective will to connect. We'll examine the forces of nature, the technical barriers that challenge even the most advanced engineering, and the human factors, politics, economics, and culture, that keep this dream just out of reach for now. Why does this short stretch of water, so tantalizingly close, remain uncrossed by a bridge or tunnel? The story of the bridge that doesn't exist reveals much about our world, and ourselves, our ambitions, and our limitations. Let's journey into the science, engineering, and politics behind this enduring dream, and discover what it truly represents. What stands in the way of connecting two continents, and what would it take to finally overcome those barriers? And what would it mean for humanity if we finally succeeded, if we built a bridge across the Strait of Gibraltar? The answer lies in the strait itself, a place where ambition meets reality and where the dream of two continents endures. The Strait of Gibraltar is a narrow, powerful gateway, one of the most iconic and challenging natural passages on Earth. It stands between the vast Atlantic Ocean and the ancient Mediterranean, where two mighty bodies of water collide and mix. At its tightest, it's just 14 kilometers wide, close enough to see the opposite shore on a clear day. But the water plunges to depths of 900 meters, forming a deep, hidden trench. Building bridge supports here would require technology beyond anything we've achieved, pushing the limits of modern engineering to new extremes. The seabed is rugged and unstable, a chaotic landscape of shifting rocks and unpredictable geology, making foundations nearly impossible. Powerful currents flow in both directions. Surface water rushes in, deep water flows out, creating constant turbulence that never truly rests. These relentless currents would batter any structure, testing the limits of engineering and endurance every single day. The region is also geologically active, where two tectonic plates collide beneath the waves, adding another layer of risk. Earthquakes are a real threat, as history has shown, with devastating tsunamis and sudden violent shifts in the earth. Any bridge would need to survive relentless water, shifting earth, and seismic shocks, an engineering challenge like no other. The strait is more than a gap, it's a fortress of natural forces, a place where the elements gather their strength. This is why, despite its short distance, the crossing remains unconquered, a challenge that has defeated every attempt so far. Nature's power here is unmatched, and every attempt to bridge the strait faces these daunting realities, often ending in failure. The dream persists, but the strait's wild energy stands guard, a constant reminder of the forces at play. It's a place where the elements rule and human ambition is put to the ultimate test, daring us to imagine the impossible. The challenge is not just distance, but the raw, unpredictable power of the planet, nature's own fortress. This is the first and greatest barrier to any bridge, a test of will and ingenuity. The Strait of Gibraltar is a living, moving obstacle, its tides and currents shifting with every hour. It's a reminder that some places resist connection, holding on to their wildness and mystery. And that's why the dream remains just out of reach, waiting for the day when human ingenuity might finally match the strait's untamed spirit. Building a bridge here is an engineering challenge like no other. The Strait of Gibraltar is not just a gap between two continents, it's a place where the forces of nature are at their most extreme, and the limits of human engineering are truly tested. The span would need to cross 14 kilometers of deep, turbulent sea, where the water is restless and unpredictable, and the distance is daunting even for the most ambitious builders. Support towers would have to rise from the seabed, hundreds of meters below, in crushing pressure and swirling currents. The ocean floor here is uneven and unstable, adding another layer of complexity. Even with advanced robotics, construction at these depths is nearly impossible. The technology required would need to operate flawlessly in one of the harshest environments on Earth. Strong winds and waves would halt work for days, stretching timelines and budgets. Weather here can change in an instant, making every day on site a gamble. The strait is also a major shipping lane, over 300 ships pass daily. Coordinating construction with this constant flow of maritime traffic would be a logistical nightmare. The bridge would need to soar high above the water, allowing massive vessels to pass safely. Its clearance would have to rival the tallest bridges in the world. Any collision could be catastrophic, threatening lives and the integrity of the entire structure. Materials must resist saltwater corrosion, withstand earthquakes and flex with the wind. Every component must be engineered for both strength and resilience. No existing bridge faces all these challenges at once. This project would set a new benchmark for what's possible in civil engineering. Every step, from foundation to final span, is a battle against nature and logistics. Each phase would require innovation and determination. The scale, depth, and danger make this project a true test of human ingenuity. It's a challenge that would push even the most experienced engineers to their limits. Even the world's best materials and methods are pushed to their limits here. Every solution must be reimagined for this unique environment. The Strait of Gibraltar is a perfect storm of engineering obstacles, where every variable is amplified and every risk is magnified. It's not just about building big, it's about building smarter, stronger, and safer than ever before. The future of bridge engineering could be defined right here. The dream demands solutions we haven't yet invented. It calls for breakthroughs in design, materials, and construction techniques. That's why, for now, the bridge remains a vision, not a reality. The world watches and waits for the day this dream might finally be realized. The mountain to climb is higher than ever, but the summit, though distant, continues to inspire. Two forces dominate the strait: deep water and unstable earth. Most long bridges are built in shallow seas with many supports. Here, the water is nearly a kilometer deep, far beyond current construction methods. Suspension bridges with 5-kilometer spans have been proposed, but the scale is unprecedented. Towers would need to rise over 1,000 meters, cables thicker than any ever made. The seismic risk is just as daunting. The bridge would sit atop a major fault line. Earthquakes could shatter rigid structures, demanding advanced shock-absorbing systems. No bridge has ever faced both such depth and seismic danger at once. If the water were shallow or the ground stable, the challenge would be less. But here, both problems are at their extreme. Nature seems to have designed this spot to resist any crossing. Only revolutionary technology could overcome these obstacles. For now, the deep and shifting strait keeps its secret. Even if we solve the engineering, human challenges remain. A bridge here would require unprecedented cooperation between Spain and Morocco. Every detail, design, funding, control, must be negotiated. The cost? Likely over 100 billion euros, with ongoing maintenance and security expenses. Who pays, who profits, who maintains it for decades? Political priorities, economic interests, and national security all complicate the dream. The bridge could shift regional power, spark debates over migration, and raise security fears. International treaties would be as complex as the engineering. Before a single stone is laid, these issues must be resolved. The human mountain may be the hardest to climb. The strait is a vital ecosystem. Millions of birds migrate here, and whales and dolphins thrive in its waters. A massive bridge could disrupt migration, confuse birds, and drive marine life away with years of noise. The piers could alter currents, affecting the entire Mediterranean's delicate balance. Even small changes could have huge, unpredictable consequences. Environmental groups and scientists warn of risks to this UNESCO biosphere reserve. Any project would face intense scrutiny and likely opposition. The dream of connection must be weighed against the cost to nature. The world's greatest bridges show what's possible, and what isn't. China's Danyang Kunshan Grand Bridge is the longest, but it's mostly over land. Japan's Akashi Kaikyo Bridge spans nearly 2,000 meters of water, built to withstand typhoons and earthquakes. France's Millau Viaduct is the tallest, its piers rising above the clouds. Each solved a unique problem, length, span, or height, but none faced all at once what Gibraltar demands. The strait would require a span more than twice as long as Akashi Kaikyo, with towers taller than Millau in deeper water and a seismic zone. These marvels teach us, but also show our limits. The Gibraltar Bridge would need to break every record at once. It's a challenge in a class of its own. The world's best bridges are stepping stones, not blueprints. The lessons are valuable, but the strait's challenge is unique. We know what's possible. Gibraltar asks for the impossible. That's why the dream endures. If a bridge is too hard, what about a tunnel? Spain and Morocco have studied this for decades, inspired by the Channel Tunnel. But the geology here is tougher: hard rock, unstable ground, and a major fault line. A tunnel would need to go deeper, under more pressure, and face earthquake risks. New ideas include submerged floating tunnels, tubes anchored below the waves, safe from ships and storms. Norway is testing this technology, but it's never been done at Gibraltar's scale. Floating bridges used elsewhere can't handle the strait's wild currents. The future may lie in a tunnel, a floating tube, or something yet unimagined. The dream is alive, and innovation continues. One day, a breakthrough may finally connect the continents. The dream of a bridge between Europe and Africa endures, but the gap remains. Nature's barriers, depth, currents, earthquakes are immense. Human challenges, politics, cost, environmental impact are just as daunting. The strait is a perfect storm of obstacles, a place where ambition meets reality. Yet the vision inspires hope. Closer ties, new opportunities, a symbol of unity. Engineers keep searching for answers. Tunnels, floating tubes, new materials. Perhaps one day technology and cooperation will unlock the solution. Until then, the Strait of Gibraltar stands as a wild, beautiful divide. It reminds us of our limits and our dreams. The story is not just about a bridge, but about the human spirit. We push boundaries even when the odds are long. The connection is so close yet still so far away, and so, the dream lives on.